so we're going to go to the RISC-V Summit.
Yeah.
What are we going to do there? What's up?
Okay, so we're going to talk about verification because that's what we do, Nikki, as you know, and we do formal verification. And you know, we love formal at Axiomise. So we're going to talk about what we're doing with formal verification and RISC-V. So I think it's only fair to capture a little bit about what simulation is used for in formal verification. So let me actually draw you a nice diagram here. So imagine time is like a linear axis, and what simulation guys are doing is they are taking instructions in RISC-V. So let's say the add instruction, and you have register 7, register 5, and register 3. So what a simulation person is doing is they are sending in specific instructions with a specific instruction payload, so register 3, register 5, and register 7, and they are checking whether the result of the add instruction on a specific processor is correct. Now, to make it more interesting, what they do is they have other instructions also here. So for example, they can have a subtraction instruction. They could have other instructions. So they will jumble them up. They will do repeated instances of sending in the same instruction or other instructions, but with a specific payload. So what happens is that simulation considers that you have an add here. Let's say you can have a sub here. You can then later on have an add I here. Then you may choose to insert a stall, but you get the idea that you can actually try and do different things, but there are way too many interleavings for you to consider in simulation. So the reason why simulation-based verification doesn't catch all the bugs is because sequence generation is very hard, because a human being has to sit and dream of all possible interleavings of these instructions with each other, with all operand payload, and has to consider all possible points, time points of insertion. So simulation doesn't scale for any big processor, so that's the main problem. So how are we actually fixing it with formal? So whereas with simulation, sequence is your pain point, with formal, this is our strength. So what happens is when you write a property checking in behavior of an add instruction in formal, in a formal verification tool, you write a property to say, can I actually get the result of RS1 and RS2 registers added into RD? What a formal tool does for you is it basically takes up an add instruction. It will do the verification of add, but it will do this for all possible firings. So this is all possible firings of add instruction. It will consider all possible other instructions before the add. It will consider all possible instructions. So there is a set of all others that would be tested after the add was issued and before it was committed. And in addition, it also considers other events. So by which I mean other events. So in other events, you have debug. And as you know, we caught bugs in processors like IPEX where the debug was causing the processor to fall apart. We can have stall, causing infinite delays and lockups that simulation won't be able to catch. We will track the role of interrupts, and formal verification tools would automatically consider the interleavings of all of these events, and again, as many as you like, infinitely many, with the interleaving of all other instructions before and after. And then if you get a formal tool to say, yes, an add instruction is proven, we are done.